The earliest supermassive black hole ever found has just been spotted. An object lurking in the foggy dawn of the universe has just given astronomers a big surprise. Observations collected through the James Webb Space Telescope have revealed an active supermassive black hole 10 million times the mass of the Sun, one that is actively growing as it slurps up matter from the space around it. At just 570 million years after the Big Bang, this is the earliest growing supermassive black hole detected yet, although scientists are hoping it won't remain the record holder for long. The black hole was found inside one of the earliest galaxies ever detected, previously known as EGSY 8P7, though since renamed CIRS_1019. Its discovery could help with one of the biggest head-scratchers of the early universe: how the black holes in the cosmic dawn grew to such large sizes in such a short amount of time. It is the most distant active galactic nucleus, AGN, and the most distant, earliest black hole we've ever found. While investigating light produced by star formation in the very early universe, this light, called Lyman alpha emission, is thought to be generated by the ionization of neutral hydrogen by star formation activity. The early universe was filled with a fog of neutral hydrogen, which prevented light from propagating. It was only after this hydrogen was ionized that light could stream freely. This epoch of ionization, as it is known, is not fully understood. We know it took place in the first billion years after the Big Bang 13.8 billion years ago, but seeing that far into the early universe is really hard. CIRS_1019 and a handful of other super-early galaxies are excellent targets for this research, because they're relatively bright. The galaxy was identified in Hubble data in 2015, and at the time, was the earliest, most distant galaxy observed. Subsequent observations confirmed its existence, but more detailed information remained elusive. The earliest light in the universe has shifted so far into the infrared part of the spectrum due to the universe's expansion that a powerful, dedicated infrared instrument like JWST is necessary to probe them. So, when JWST came along, CIRS_1019, the brightest of the Hubble galaxies from this epoch, was an obvious target. The telescope stared at the galaxy for just 1 hour, with all 4 of its instruments, but returned a wealth of data. Typically, a galaxy in the early universe emits either light from an AGN or light from star formation. To see both in the same galaxy was extremely unexpected. There is some impact that the black hole is having on the emission lines that we're seeing, but most of the light we see in our images is still dominated by the star-forming part of the galaxy. That a supermassive black hole existed more than 13.2 billion years ago, and was seen growing, is not as surprising as you might think. Much larger black holes have been detected in the early universe. J1342+0928, a quasar galaxy detected 690 million years after the Big Bang, has a supermassive black hole clocking in at 800 million suns. The black hole in J0313-1806, 670 million years post-Big Bang, was measured at 1.6 billion suns. Both of these quasars are dominated by AGN emission. Looking at the supermassive black hole in CIRS_1019, the researchers think the object formed from the collapse of a massive object, such as one of the first stars in the universe. These stars were much bigger than the stars we have around today, so the black hole from such a collapse would have had a head start on its path to becoming supermassive. I hope you found this video interesting. Consider subscribing. Explore for more similar contents like this. You might be interested in these videos. I highly recommend you to watch these videos.